All right, don't have your textbooks out. We're going to get to some things here in just a moment, but before we turn in our books, I want to review some things from our last couple of lessons. We began a chapter talking about different shapes that result from a right circular cone being intersected by a plane. What do we call this group of figures that could be formed? Conic sections, good. And we said this chapter is going to deal with 4 conic sections specifically.
Circle, ellipse, parabola, hyperbola.
And interesting the order that she presented that. She went in order of how weird they are. Circle, ellipse, parabola, hyperbola. That how weird they are term, we could call it, is called? Eccentricity. Good, the eccentricity of the conic. In general, all of our conics will fall into one basic equation form, just with differing numeric values here and there. What's our conic form of equations here, Jamie?
Ax plus by plus c.
That's the general form of a linear equation, which a linear equation or a line is a conic, remember, from where a plane touches the edge of the cone. Quentin, help her?
Ax squared plus by squared plus cx plus dy plus d equals 0.
There we go. All of our conics are going to fall into this form. Now, Jamie, if we took this, we essentially have what you said, right? I mean, the letters are only placeholders anyway, showing there's some numeric value or some constant there. But x, y, constant equals 0 is basically a linear equation. What we've been working on lately have been circles. And circles, of course, remember, have both x squared and y squared, and by the way, have matching values here. We're getting a little ahead of myself there, though. What we've been working on with the circle, though, had a special equation of a circle. So rather than the conic form starting out, we started off with the circle form. What is the circle form of an equation, Jamie?
X minus x1 squared plus y minus y1 squared equals r squared.
There we go. And so, for instance, if I knew that the center of a circle was, say, 3, -2, and I knew that the radius was, say, the square root of 13 units, what would that equation look like, Quentin?
X minus 3 squared plus y plus 2 squared equals 13.
Good. So this would be the equation of that circle. What if I were giving you the equation of a circle? I said, for instance, we've got an x plus 5 squared plus y minus 4 squared is equal to, say, 35. Well, Jamie, based on that equation, I can deduce or pick out the center and the radius.
So the center is -5, 4, and the radius is square root 35.
Right, which if I were actually graphing this, right, that radius would be almost 6 units, correct? Not quite, but almost 6 units. Questions on this? This is stuff we've been working on. Now, I want to take you back, though, to the conic form, and a couple of things for you to know. First of all, if A and B are equal, then you know you're going to get a circle. So equal and positive. If they're equal and both positive, you know you're going to get a circle. And we've seen this before, haven't we? In fact, the basic form of a circle is x squared plus y squared equals something, which happens to be an r squared. This is the basic conic form for a center at the origin. This is the basic conic form of a circle if the center is at the origin. Now, of course, we change it to say x minus x1 squared plus y minus y1 squared equals r squared for if the center had moved. If the center moves, we have what's called a translated origin. A translated origin. It's as though the origin has shifted from its original position there at 0, 0. And of course, we know in the circle form, it becomes x minus x1 squared and y minus y1 squared. But you understand that these values cause a translated origin. If these values aren't there, of course it's just x squared plus y squared equals r squared. It's when these values are present that it shifts the origin. So what we want to work on today is, what if we started here in the conic form? How would we figure out where the center is and what the radius is? For instance, write this down. If we had x squared plus y squared minus 6x plus 2y is equal to 6. That's a circle. How do I know it's a circle? Just by looking at the equation. The x squared plus y squared is the giveaway. In fact, if you'll jot this down, you need a and b to equal positive 1. You're going to need a and b to equal positive 1. Now, technically, if they're at least positive and equal, in fact, really, one could argue if they're both negative, then you could just change the signs anyway, so you could make them positive, right? So really, as long as they're equal, you've got a circle, but you really need them to be a positive 1 in each case. I can tell by looking it's a circle. I also can tell, because there's more here than meets the eye initially, I know my center's been translated. Where? How? I also don't see the radius right now. Square root of 6 is not going to be my radius, but I can tell it's a circle. So the question is how to get from this conic form into the center radius form that I erased a moment ago. Step number 1, you're going to want to group your x and y terms. Group your x and y terms. Conic form calls for you to descend the order, right? To have your x squared, your y squared, your x, then your y, then your constant equal to 0. What we're going to want to do is group the x's and y's. So, write this down with me. I'm going to put the x squared and the negative 6x together. I'm going to put the y squared and the positive 2y together. And I'm going to kick out the constant if it weren't already kicked out. Obviously, in this case, I already started the e, or the constant value, off on the other side. But we're going to kick out the constant. So group x and y terms and kick out constant. That's kind of implied by a grouping because it doesn't fit in anywhere, right? Kind of like the toys on the Island of Misfit Toys and Rudolph. Right? Such a terrible movie, bullying and whatnot. Anyway, I'm kidding. All right, anyway, it's not Christmas time. Where are we talking about this? All right, step number 2. Because you have made this a 1x squared, and you've made this a 1y squared, then as you group your x squared minus 6x, you've got the start of a perfect square trinomial. And you've got the start of another perfect square trinomial. So what we're going to do in step number 2 is complete the square twice. Complete the square twice. We're going to figure out a number that needs to go right after the x squared minus 6x, and a number that needs to go right after the y squared plus 2y. Remember, to complete the square, we have 2 steps. We half and square. Say that with me? Half and square. So if I half, I get negative 3, and I square it to get a positive 9. Now the nice thing is, you really don't even have to worry about positive or negative because you're going to square anyway. So half is basically 3, squared is 9. Half is, squared is 1. But realize you always get a positive when you complete the square. So a positive 9 kind of comes down here, and there's my perfect square trinomial. The 1 comes here, we have our perfect square trinomial. But what we do to one side, have to do to the other side to maintain equality, right? So I can't arbitrarily add a 9 and a 1 over here unless I offset it by also adding a 10 to offset the 9 and 1 over here. So complete the square and add to the other side. Complete the square and add to the other side. Step number 3, form binomial squares. Form binomial squares. Again, a perfect square trinomial factors into a binomial squared, and after all, in the center radius form, or the circle form, it's what we want, right? We want an x minus x1 binomial squared. We want a y minus y1 binomial squared equal to something which happens to be my r squared. So here, this becomes, class, x minus 3 squared. This becomes
y plus 1 squared.
And of course, that's just 16. Ah, so what is my center of my circle?
3, -1.
3, -1 is my translated center. And what is the radius?
4.
4. We couldn't see it in the conic form. The conic form is a nice, neat, no parentheses form that's consistent across all conics. The center radius form is helpful. So we've been working the past 2 days with the center radius form or the circle form, but we need to be able to work from the conic form as well. The key is get it into this form. Boom, see center, see radius, really quick and easy. Questions on that? Look at your textbook if you would now at page 231. Look at your textbook if you would please, page 231. Look at the example problem. It says find the center radius, then graph the circle, and they give us a circle 2x squared plus 2y squared minus 20x plus 4y plus 36 equals 0. Well, of course, if I want that equation, if I want to know the center and radius, I got to get it out of the conic form class and into the circle form, right? But the problem is I said you've got to have what numbers here? Ones. Now, the fact I know it's a circle because they're the same number, right? That tells me it's a circle, but I need ones right here. So to get ones, what would I have to do? Take 2 out of everything. And conveniently, it's easy to take a 2 out of everything, Jamie.
X squared plus y squared minus 10x plus 2y plus 16. Right now, the other thing.
She's like, if only I had a calculator, I
18.
figured it out. Hey, she don't need no calculator. 18 equals 0. There we go. So step number 1, get the positive ones, right? And then when they did that in the example problem. Then, class, we're ready to group the x and y terms. So you see what they did there. Now, here's my suggestion. When you group your x terms, leave a little gap. When you group your y terms, leave a little gap. And then, of course, we got to kick out the constant as a... What goes in the first gap?
25.
A 25, right? Half and squared. What goes in the last gap? 1. So what do I add to the other side?
26.
A 26. So this is going to give me a binomial squared from this PST, a binomial squared from that PST, and of course a number on the end. What are the binomials here, Quentin?
X minus y squared, y plus 1 squared.
And it's all going to be equal, class, to 8. So what's the center?
5, -1.
5, -1. What's the radius?
Square root of 8.
Square root of 8, or 2 times the square root of 2 units, which is about 3. It's about 2.8, a little less than 3. Look at the picture in the book. You see there they put the center, the translated origin at 5, -1. And then they went almost 3 in all directions and drew a circle. Again, a compass really helps if you had to graph one of these. Does that make sense? Questions on that? All right, turn over to page 232. At your seats, I want you to do number 1A. They've given you a circle. We know it's a circle because it's x squared and y squared, but notice they already did the grouping for you, and they already kicked out the constant. You just got to finish it out on letter A. Circles are easy in the circle form. So what do you do if it's the conic form? Get the circle form so it can still be easy. We're lazy. Easy is fun. Or at least better than hard. All right, what goes in the, oh, that's a minus. What goes in the first gap, class?
1.
A 1. Hopefully as you copied it down, you left yourself a gap. What goes in the next gap?
4.
So what also goes on the other side?
5.
5. This becomes,
X plus 1 squared
this becomes,
minus 2 squared
and this becomes.
9.
So Jamie, what's the center?
-1, 2.
And what's the radius, Quentin?
3.
And if we were to graph, right, we would go backward 1, upward 2. We'd go 3 in all directions. And we'd use our compass if we had one. to make a circle, something like that. It looks better, of course, with a compass, but we get the idea. Questions? Do letter E now. Look at letter E. You got an x squared plus y squared plus 3x. Now notice there's not a y. Right? If anything, there were a plus 0y. Right? And they went ahead and kicked out the constant and said equals 4. So when I group my x's, what does it look like?
X squared plus 3x plus.
I'm going to leave a gap, and then just a y squared. I don't want to put a plus 0y plus 0 because that's too much writing, correct? So the fact that there is no y just means that the origin hasn't been translated vertically. Does that make sense? Because there's not a y to the first. Y to the first translates it somewhere, just like an x to the first is going to translate it. All equal to 4, and of course we're going to have to add something. Now here we have an odd number. Highly unfortunate, right? But what is half of 3? 3 halves. Let it be easy. 3 halves, which when you square it gives 9 fourths. As opposed to 1.5 squared is 2.25. No. We don't want to do that. And if we add 9 fourths here, have to add 9 fourths here. Now here's where it kind of could get sticky. I've got a 4. That's a 4 oneths, 4 firsts, right? I need fourths. 4 firsts becomes how many fourths? 16 fourths, which added to 9 fourths gives me 25 fourths. Here, we have the plus y squared. Here, we need to make a binomial squared. What is the binomial, Quentin?
X plus.
Are we going to take the square root of 9 fourths?
3 halves.
3 halves. So where's the center of the circle, Quentin?
Negative 3 halves. 0.
Good, negative 3 halves, and of course 0 because we didn't shift the origin vertically. Jamie, what's the radius?
5 halves.
5 halves. Now, practically speaking, that's 2.5. That's negative 1.5. So if I were to graph this, I would go backward 1.5, up and down nothing, and then my radius is going to be 2.5 in all directions. Usually I just do the 4. Of course, this is poorly drawn Cartesian plane, but we get something like that. Does that make sense? Mm-hmm. So on the surface, like, oh man, fractions, it actually didn't work out so bad, right? Questions? Let's take a look at letter G. Letter G. At your seats, do have a very similar problem. Except not the odd number. And so, Quentin, what did you get for your center?
Negative 2, 0.
Good, negative 2, 0, and a radius of, Jamie? 2. Good to go on that? All right, if you have questions on that one, and you're watching on YouTube, let me know, I'll help you, but I felt like they had this down pretty well at this point. Take a look at example number 2 now, if you would, please. Example number 2. And read that problem there for us, if you would, Jamie.
Find the equation of the circle concentric with and having twice the radius as the circle, x squared plus y squared plus 4x minus 6y equals 23.
Okay, concentric with. There's a good term from geometry. What does concentric mean?
Same center.
Having the same center. Okay, but it says having and also have, so we want a circle that has the same center as their circle. Does that make sense? They give you that circle. That's not our circle, that's their circle. But we want the same center. We also want our radius to be twice as big, which, think about it, if you have like a bullseye or something, however big the first circle is, you want that radius doubled to make it look nice and symmetric for the next one, correct? I don't know why the chalk came off the board right there. All right, we're going on doubled radius. That's what we're looking for. What's going to be the equation of the double radius circle? All right, so let's start by, if it's going to have the same center, I need to know what is the center. And if my radius is going to be doubled, I need to know what is the radius. So let's take their circle. X squared plus y squared plus 4x, is it plus 6y minus 6y equals 23? Let's figure out their center. Well, first of all, class, we,
get like terms.
well, not like terms,
like
but
X and Y.
good x's and y's grouped. X squared plus 4x, y squared minus 6y, and of course the constant was already kicked out. We complete the square with a
4.
and a 9, and after here we also put 13. All right, so here, Jamie,
It's gonna be x plus 2 squared, y minus 3 squared, and 36.
okay, so their center is
Negative 2, 3.
-2, 3. So my center needs to be, class,
Negative 2, 3.
because it's going to be concentric. Their radius is
6.
6. So my radius needs to be 12. Make sense? They said find the equation of this circle, the one that's concentric to this one and has a doubled radius. So now we need to find the equation of the circle. Well, if I know the center, I know the radius, let's plug it into the circle form, class.
X plus 2 squared plus y minus 3 squared equals 12. Wait, 144.
Good, equals 144. And what I'd like to do is go ahead and put that back into the conic form so we can compare our circle with the one that we are concentric to. So let's go ahead and finish it out here. Let's reverse the process now. Square the first square, last multiply and double.
X squared plus 4x plus 4. And y squared plus 6y, or minus 6y plus 9 equals 144.
And of course, to be in the proper conic form, we want the x squared, then the y squared, which we already knew would be an x squared, y squared, just individually. Then we want the 4x and the negative 6y. And if we're matching what they did, they actually put their constant here at the end. Technically, conic form calls for it to be before. A lot of times with circles, we'll see it at the end. If we were to leave it there, that means I'd have to take 13 away, and then with equals.
131.
Now look at these two equations. What do you notice is similar about them?
X and Y are the same. Oh, X. Yeah.
Everything before the constant is the same. That's how you see concentric circles. The question is, what's the ending number? And this would have either a negative 23 equals 0 or just equals 23. Notice the numbers aren't doubled. So you can't say, well, I'll just keep the same beginning and double the number. No, that's not going to give you a doubled radius. A little bit more involved than that. But questions? Do we see how, starting out, if all the variables have the same coefficients, we will have concentric circles? All right. Another interesting problem is example number 3. And read this here if you would, Quentin.
Show that x squared plus y squared minus 4x plus 8y plus 25 equals 0 is not a real circle.
Is not a real circle? Huh. Here's the point they're making. Just because I say x squared plus y squared doesn't guarantee a circle exists. I'm like, well, I'm even going to translate the center. Minus 4x plus 8y. See, I just translated the center. And plus 25 equals 0. Can I, as the math teacher, just make up something and say, boom, circle? No, this isn't a circle. Let's show why not. Well, again, to start out, we group the x's and y's, right? So x squared minus 4x, Jamie.
4.
Plus 4. Plus y squared plus 8y, Quentin.
16.
Plus 16 equals, I'm going to have to kick out the 25 as a negative, but I'm going to add to the other side, class, 20. And of course, this gives me an x negative 2 squared plus y positive 4 squared equals negative 5. So that means the center, class, is
2, negative 4.
2, negative 4, and the radius is the square root of negative 5? An imaginary radius? Not a real circle, is it? So no, you can't just make up whatever. Oh, poof, a circle comes out. No, because you have to have a real radius, not an imaginary one. Questions on that? All right, look at page 232, section number 2. And it says, determine which of the following equations actually represents a circle with a real non-zero radius. By the way, a radius of 0 would just be a point, wouldn't it? A radius that's imaginary is definitely not a circle either, right? So there are 4 circles here. Which of them are real circles? Well, let's take a look at 2a and let's determine, is that a real circle? X squared plus y squared plus 10x equals negative 3. Let's see if that's actually a circle. What do we need to do, Jamie?
You group the terms together and
So-
complete the square. So x squared plus 10x plus 25 plus y squared. That equals negative 30 plus 25.
And we don't even have to go further. Is it going to be a real circle, class? No, because we end up with a negative value, kind of like the same thing in fact here, negative 5. It's not going to be a real circle. Let's drop down to letter C. What am I going to have to do first though on letter C? I can't do that. I'm going to pull a 4 out of everything. What do I get when I pull a 4 out of everything, Quentin?
X squared plus 18 fourths x plus something plus y squared minus 2y plus 1 equals negative 8 5 4.
Yeah, we pull a 4 out of everything. He will try to do lots of steps at once, okay, which is admirable. X squared plus 18 into 4 x plus y squared minus 2y equals negative 85 fourths. He went ahead and completed this square. Before we complete this square, let's reduce it down a little.
9 halves.
Let's make it 9 2ths, or 9 halves. Now remember, we take half and then we square. What is half of 9 halves?
9?
Half of 9 halves. 9 fourths. And then we have to half and square. 81 sixteenths. Okay, so not terribly hard, doesn't require a calculator, but a little annoying perhaps, right? Okay, now, if we added this and we added this on this side, we also have to add it to the other side, so let's also add.
97 16.
Okay, I like it, put it all together, 97 sixteenths. So we have the 81 sixteenths and the 16 sixteenths. However, they don't have a common denominator, so this has to be rewritten. And this is where a calculator might help unless you're really good at multiplying by 4. 340. Negative 300. Yes, negative 340 sixteenths is correct. Now, here I would get something. Here I would get something. Of course, you can always get a center of a circle. But what about my radius? It's still going to be negative, right? So it's still going to be an imaginary radius. So again, neither 2A nor 2C is a real circle. What about 2B? Or not 2B? That's your seats. Figured out, is that a real circle? That's your seats. Figured out if 2B is a real circle. So, we divide everything by 3, correct? And that gives us x squared minus 11 thirds x plus something plus y squared equals negative 91 thirds. The something you have to half, which when you half it becomes 11 sixths, squared becomes 121 36, correct? That means we also have to add 121/36 over here. To get a common denominator, top and bottom have to be multiplied by 12. That gives me 36 here, and whatever 91 times 12 is. I'm lazy enough pulling up the calculator. Is 91 times 12 going to be more or less than 121? Way more. So it's negative, way more, positive, little. Still going to be no circle. All right, make sense? All right, let's drop down to number 3 now and move off of that topic and stop talking about things that don't exist. And number 3, read that for us, Jamie.
Find the equation of the circle which passes through 5, 3 and is concentric with x squared plus y squared plus 2x minus 4y equals 0.
There we see that word concentric again. If it's concentric, it means it has the same center. So, figure out what the center of the circle is going to be. Remember, 2 things we have to know, class. Center and radius. Jamie, what are the 2 things I have to know? Center and radius. They're telling us the center by telling us it's concentric with this one. So let's figure out our center. What's the center of their circle, class? Negative 1, 2. So what's the center of my circle? Negative 1, 2. That's the first thing. Figure out the center. I don't care what their radius is, because my circle doesn't have the same radius, does it? And unlike the example problem where we'll double the radius, I don't even care. I don't care what their radius is. I know my circle is going to share their center, and my circle has to go through the point 5, 3. Now, what are the 2 things I have to know? Center radius. That's not the radius. But it can tell me the radius because, what is the radius? Simply the distance from the center to any point on the circle. So if I find this distance, that's my radius. So what's my radius going to be, Jamie?
Square root of 37?
Square root of 17.
Careful. We find a change in x. 6 squared. 36. Change in y. 1 squared. 1. And we add those together to get the square root of 37. Did you say 37? I didn't hear the 30. All I heard was 7. I'm like, and it just dawned on me with the look on your face. I'm like, I think she might have said 37. Okay, I just heard square root of 7. I'm like, square root of 7? Where'd she get 7 from? Okay, 37. All right, so Cameron, if you heard her, great. All right, so this is my circle. They want to know the equation of my circle. Well, let's start with the easy form. What is it going to look like initially here, Jamie?
X plus 1 squared plus y minus 2 squared equals 37.
There we go. And then let's put it back in the conic form so it matches the look of their equation, Quentin.
X squared plus 2x plus 2, or 1, plus y squared minus 4y plus 4 equals 7.
And let's make it look really good now, Jamie.
X squared plus y squared plus 2x minus 4y plus 5, right?
Equals 37.
Equals 32.
So then if we wanted to set it equal to 0, which is the true conic form,
32. 32, negative 32.
negative 32. There we go. And there we go. And notice, our equation starts off the same as theirs, and we knew it would, right? Because it's going to be conic. It's going to be concentric. It's just ours has a negative 32, and theirs had a 0, if you will, right? Questions on this. And there is another way you could solve it, okay? That's actually a little bit quicker. Their equation starts x squared plus y squared plus 2x minus 4y, and they said equal to 0. That's their circle. Even if their circle had been plus 17 equals 0. I know my equation at least has to start like that, correct? And it must end with an equals 0. So another way we could have solved this, well, I know mine's going to be x squared plus y squared plus 2x minus 4y, and I know it's going to end equals 0. And it goes through the point 5, 3. 5 being an x value somewhere in the circle, 3 being the corresponding y value somewhere in the circle. 25 plus 9 plus 10 minus 12, something has to make that equal 0. Well, if you added all of this together, we end up with a positive 44 minus 12 gives me a positive 32. That doesn't equal 0. What would offset the 32 to help it equal 0? A negative 32. And now it equals 0. So there was a shortcut there. I wanted you to understand the long method first, and then, oh, okay, I kind of see what's going on there. Okay, questions on that? All right. Well, we'll talk a little bit more about circles as we wrap this up in our next lesson, but our next lesson is not going to be until after spring break. So if you're watching on YouTube, take about a week off and come back later, and we'll finish up circles, and then we'll, of course, move into our other conics as well. Because of spring break, no homework this evening, or for the next week and a half, really. Have a wonderful spring break, and we'll see you after you've had a chance to get some rest for the last 8 weeks of high school. Unless, of course, you flunk out and repeat. I'm just kidding. They're not going to flunk out and repeat. Bye-bye.